Let us take a positive integer 24. 24. So 24 can be factorized like this: 2 12 jar, 2 6 jar, 2 3 jar. That means 24 is equal to cube into 3 power 1. Now, when we express it as the product of prime factors, 24 will be expressed as 2 power 3 into 3 power 1. Now, number of integral divisors. So, how many 2's are there in these factors? There are 3 2's and there are 1 3. So, 24 can be expressed as the prime factors of 2 kinds of prime factors. So, first kind of prime factors are how many? 3. And second kind of prime factors are 1. So, one kind of prime factors are 3 and another kind of prime factors are 1. From these 3 plus 1, 4 prime factors. Now, as many combinations as we made, so every combination will be a factor of 24. The 3 plus 1 ఈ ప్రైమ్ నంబర్స్ లోంచి ప్రైమ్ ఫ్యాక్టర్స్ లోంచి మనం ఎన్ని కాంబినేషన్స్ ఫామ్ చేయగలిగితే ప్రతి కాంబినేషన్ కూడా ఈ 24 యొక్క ఫ్యాక్టర్ అవుతుంది. చూద్దాం ఎట్లానో అది. సో యాక్చువల్గా అకార్డింగ్ టు దిస్ ప్రీవియస్ ఫార్ములా, హౌ మెనీ కాంబినేషన్స్? ద నంబర్ ఆఫ్ కాంబినేషన్స్ that can be made from 3 plus 1 things. And 3 things are alike of one kind and one thing is alike of second kind. Is equal to what? 3 plus 1 into 1 plus 1. This is equal to 4 into 2. This is equal to 8. So there are 8 factors, 8 divisors of this 24. So let us write what are those 8 divisors. 1, this is the common divisor, trivial divisor of every number. Without taking anything, we will get this combination 1. And 2, if you take 2 2's, that is 4. If you take 1 2 and 1 3, we get that combination as 6. And this is single element, choosing of single element. 2 3 also it will come. 2 3, right? So 2 and 3. These are the combinations. First one is the combination without taking any element. So 2 and 3 are the combinations by taking one element every time. And now by taking 2 elements every time. So we can take any 2 of these 3 2's. That is 2 into 2, 4. And 1 2, 1 3, 6. Right? And no other. And by taking 3 elements at a time. So all the 3, 2 into 2 into 2, 8. And 2 2's and 1 3, 12. Right? And next, by taking all the 4, 24. So how many factors we got here? 1 2 3 4 5 6 7 8. So the total number of factors is 8. These are the 8 combinations we can make, and every combination gives a factor of 24. So therefore, when this 24 is expressed as the product of prime factors like this 2 power 3 into 3 power 1, then the number of integral divisors of 24, therefore the number of integral divisors, this is called integral divisor, finding the integral divisors of a positive integer, number of integral divisors of 24, which is equal to 2 power 3 into 3 power 1 is equal to what? 3 plus 1 into 1 plus 1, that is equal to 4 into 2 is equal to 8. So now let us generalize this. If n is any positive integer and when it is expressed as the product of prime factors p1 to the power of alpha 1 into p2 to the power of alpha 2 into p3 to the power of alpha 3 into and so on into pk to the power of alpha k, then the number of integral divisors, of n is equal to the number of combinations that can be made from alpha 1 plus alpha 2 plus alpha 3 and so on plus alpha k elements in which alpha k are of similar of one type and alpha 2 are similar of second type and alpha 3 are similar of third type and so on alpha k are similar of k type of elements. So that is equal to alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 and so on into alpha k plus 1. So this is the formula to find the number of integral divisors of a positive integer n when it is expressed as the product of prime factors in the form of p1 to the power of alpha 1 into p2 to the power of alpha 2 into p3 to the power of alpha 3 and so on into pk to the power of alpha k. So in these 1 and the given number included in this number of prime factors, not number of integral divisors. So then we can have another two formulas. The number of integral divisors of n excluding 1 and n is equal to what? This total number of integral divisors that can be formed and so on, alpha k plus 1 minus 2. What are these minus 2? What these minus 2 we are subtracting? So 1 and itself, 1 is the integral divisor obtained without taking any element in the combinations. And this n, the number itself given, this is obtained when by taking all the factors at a time. So ఏది తీసుకోకుండా ఏర్పడే కాంబినేషన్, అన్ని తీసుకొని ఏర్పడే కాంబినేషన్స్ ఇవి ట్రివియల్ డివిజర్స్ అవుతాయి. వీటిని ట్రివియల్ డివిజర్స్ అంటారు. సో ఎక్స్క్లూడింగ్ దీస్ ట్రివియల్ డివిజర్స్, ద నంబర్ ఆఫ్ నాన్ ట్రివియల్ డివిజర్స్ ఆఫ్ దిస్ ఇంటిగ్రల్ డివిజర్ n is equal to alpha 1 plus 1 into alpha 2 plus 1 and so on alpha k plus 1 minus 2. So this is the formula here. It is derived, right? And next slide is the positive divisors of n other than 1 and itself. So already we have gone through this. And next formula is to find the exponent of a prime in n factor. The exponent of a prime in n factor. The definition of exponent of prime in n factor. Write down. Exponent of a prime p in n factor is the largest integer k such that p power k divides n factor. Exponent of a prime p in n factorial is the largest integer k such that p power k divides n factorial. So n factorial lo p ane oka prime number yokka exponent ఎంత ఉంటది అంటే it is the largest integer k such that p power k divides n factorial. So this is the formula to find the exponent of p in n factorial. So bracket of n by p plus bracket of n by p square plus bracket of n by p cube plus and so on. So this formula is given without proof. So ఈ ఫార్ములా మనకు ప్రూఫ్ లేకుండా ఇచ్చారు. సో ఇదేంటంటే n ఫ్యాక్టోరియల్ యొక్క విలువలో p అనే ఒక ప్రధానాంకం యొక్క ఘాతం ఎంత అంటే k యొక్క అత్యధిక విలువకు p పవర్ k కనుక n ఫ్యాక్టోరియల్ ని డివైడ్ చేస్తే అప్పుడు k ని p యొక్క ఎక్స్పోనెంట్ ఇన్ n ఫ్యాక్టోరియల్ అని అంటారన్నమాట. రైట్? Now, this is the example to find the exponent. So this is the best example and important example here. Find the number of zeros in 100 factorial. 100 factorial any zeros untai kanukomantunnadu. So when 100 factorial is expressed as product of prime factors like 2 power alpha, 3 power beta, 5 power gamma, 7 power delta and so on. మరి ఇందులో ఎక్స్పోనెంట్ ఎన్ని జీరోస్ ఉంటాయి, ఒక నంబర్ లో ఎన్ని జీరోస్ ఉంటాయి అంటే that depends on 10 power k, exponent of k number of zeros ఉంటాయి. 10 power k ఈ 100 factorial ని 10 power k కనుక డివైడ్ చేస్తే so this value k represents the number of zeros in the 100 factorial. మరి 10 power k, but 10 is not a prime number. 10 power k can be written as 2 power k into 5 power k. That means we have to find the exponent of k, exponent of 2 in 100 factorial and exponent of 5 in the 100 factorial. The intersection of exponent of 2 in the 100 factorial and exponent of 5 in the 100 factorial. రెండిటి యొక్క minimum, the least of or the minimum of exponent of exponent of 2 in 100 factorial and exponent of 5 in 100 factorial. That is equal to number of zeros. So ఇక్కడ అదే చేశాడు చూడండి. So exponent of 2 కనుక్కున్నాడు first alpha value. Exponent of 2 in 100 factorial is equal to what? Bracket of 100 by 2, bracket of 100 by 2 square, bracket of 100 by 2 cube, plus bracket of 100 by 2 power 4, right? Plus and so on. ఇది ఎంతవరకు అంటే bracket of 100 by 2 power 4, 100 by 2 power k less than 1 అయినప్పుడు then bracket of 100 by 2 power k becomes 0. అంటే ఇది 0 అయ్యేంత వరకు అన్నమాట. ఈ టర్మ్ 0 అయ్యేంత వరకు, టర్మినేట్ అయ్యేంత వరకు. సో 100 by 2 50, bracket of 50 is 50. 100 by 2 square, bracket 100 by 4 25. 100 by 2 cube, 100 by 8. So 100 by 8. So 100 ని 8 తో డివైడ్ చేస్తే 12 times. 12 point something అవుతుంది. So the bracket of 12 point something is 12. So this is. So next bracket of 100 by 2 power 4. 100 by 2 power 4 is 6. Bracket of 100 by 2 power 5 is 3. Bracket of 100 by 2 power 7. 2 power 5. 100 by 2 power 7. So the next term is becomes 0. Therefore, the index of 2, exponent of 2 in 100 factorial is equal to 97. Similarly, exponent of 5 in 100 factorial is 24. Therefore, the minimum of 24 and 97 is 24. Therefore, the index of or the exponent of 10 in 100 factorial is 24. Therefore, number of zeros in 100 factorial is 24. Okay. And next example, if there are 5 alike pens and 6 alike pencils and 7 alike erasers, find the number of ways of selecting any number of things out of them. So this is the clear example which suits the formula p plus 1 into q plus 1 into r plus 1 minus 1. So 5 things are alike of one kind, 6 things are alike of second kind, 7 things are alike of third kind. Then the number of combinations by selecting any number of elements, one or more at a time, is equal to what? 5 plus 1 into 6 plus 1 into 7 plus 1 minus 1. That is equal to 335. Okay. Now we will do some other problems from exercise. Okay. See the problems in the exercise. So let us do this question. 7th question. Find the number of ways of selecting 5 books from 9 different mathematics books such that a particular book is not included. From 9 different books, number of ways of selecting 5 books such that one particular book is not included. ఇచ్చిన 9 different mathematics books లోంచి 5 mathematics books ని సెలెక్ట్ చేసుకోవాలి. అయితే ప్రతి సెలెక్షన్ లో కూడా, ప్రతి కాంబినేషన్ లో కూడా ఒక పర్టికులర్ బుక్ ఎప్పుడూ ఉండకూడదు. సో గివెన్ డిఫరెంట్ బుక్స్ ఆర్ హౌ మెనీ 9 and number of particular books is equal to 1 and books to be selected every time is equal to how many? 5. So we have the formula related to this. From n distinct elements, from n distinct elements, or elements can be selected, such that one particular thing is not included in any selection. ఒక పర్టికులర్ థింగ్ ఏ సెలక్షన్ లోనే ఉండదు, అసలు సెలక్షన్ లో పార్టిసిపేట్ కావద్దు. సో అప్పుడు ఏం చేస్తాం, మనం ఆ పర్టికులర్ థింగ్ ని మనకి ఇచ్చినటువంటి n థింగ్స్ నుంచి ఎలిమినేట్ చేస్తాం. సో నౌ ద థింగ్స్ వి విల్ హ్యావ్ ఇన్ అవర్ హ్యాండ్ విల్ బి n-1. నౌ ఈ n-1 థింగ్స్ నుంచి మనకు కావాల్సిన ఆర్ థింగ్స్ ని సెలెక్ట్ చేసుకుంటే ఏ కాంబినేషన్ లో లేదా ఏ సెలక్షన్ లో కూడా ఆ పర్టికులర్ థింగ్ మనకు కనిపించదు. సో దేర్ఫోర్ నౌ ద ఆన్సర్ ఈస్ ద నంబర్ ఆఫ్ వేస్ సెలెక్టింగ్ 5 books from 9 different books such that one particular book is not included. One particular book is not included is equal to 9 minus 1 C5, that is 8C5. 8C5, that is equal to 8C3 also. 8C 8 minus 5. So this is equal to 8 into 7 into 6 by 3 into 2 into 1. 3 to just 6 is equal to 8 into 7, 56. So in 56 ways we can select 5 books from 9 different mathematics books. Right, next question, we will see this 9th one. Number of diagonals in a polygon of 12 sides. So here the formula related to this question. Number of diagonals of a polygon of n sides. n భుజాలు ఉన్నటువంటి ఒక బహుభుజిలోని కర్ణాల సంఖ్య is equal to nc2 minus n. So on simplification we get n into n minus 3 by 2. మరి ఇక్కడ ఒక బహుభుజిలో కర్ణము అనగా, అంటే బహుభుజిలో కర్ణము అనగా మనము ఫర్ ఎగ్జాంపుల్ తీసుకున్నాం A B C D E F example. So this polygon has 6 sides and 6 vertices, right? So in a polygon of 6 sides, it will contain 6 vertices. Then a diagonal means the line joining any 2 vertices which are not adjacent. ఈ పక్కపక్కన ఉన్నటువంటి వర్టిసెస్ ని కాకుండా ఇంకే వర్టెక్స్ ని కలిపినా కూడా వచ్చేటువంటివన్నీ డయాగనల్స్ అవుతాయి. సో AD, AC, AE, BD, PE, అలాగే CF, CE, ఇవన్నీ డయాగనల్స్. ఇంకో రకంగా ఏమని చెప్పొచ్చు, ఇన్ ఏ పాలిగాన్ ఆఫ్ 6 sides, the lines that can be formed other than the sides are called polygons, diagonals. n భుజాలు ఉన్నటువంటి బహుభుజిలో n శీర్షాలు ఉంటాయి. ఈ n శీర్షాలను కలిపితే ఏర్పడే సరళ రేఖల నుండి ఈ బహుభుజి యొక్క n భుజాలను తీసేస్తే వచ్చేటువంటి సరళ రేఖలను కర్ణాలు అంటారు. The diagonals in a polygon are nothing but the number of straight lines that can be formed by joining the n vertices minus the n sides of the polygon. So the number of straight lines that can be formed by joining these n vertices is equal to what? To get a straight line, we have to select two vertices at a time, two vertices every time. So as many times as we select two vertices, so that number of ways we get the straight lines. So from n vertices, the number of straight lines that can be made is equal to number of ways of selecting two vertices, that is NC2. So these are all straight lines. This represents all straight lines that can be formed from these n vertices. Now, out of these all straight lines, if we subtract the n sides of the polygon, then the remaining straight lines, they represent the number of diagonals of a polygon. So this is the formula to find the number of diagonals of a polygon. Now, by using this formula, we can find the answer of this question. Now, number of sides of the polygon is equal to how many? 12 sides. Therefore, number of diagonals is equal, by using this formula, 12 into 12 minus 3 by 2. This is equal to 12 into 9 by 2. So 9 into 6, 54. So 54 diagonals can be formed in a polygon of 12 sides. Okay. Now we will take up another problem. This third bit, second problem. If a set has 12 elements, find the number of subsets of A having, question number 1, 4 elements. Question number 2, at least 3 elements. Question number 3, at most 3 elements. So here from a set A which contains 12 elements, the subsets of A. Subsets of A means every subset of A is nothing but a combination that can be made by taking some elements of A. Now, what kind of combinations you are asking? The combinations with 4 elements, fixed elements this is, and combinations that can be made 3 elements at least 3 elements. అంటే కనీసం 3 elements. అంటే 3 గాని అంతకంటే ఎక్కువ గాని ఉండొచ్చు అన్నమాట. At most 3 elements. అంటే maximum 3 elements. At most 3. అంటే less than or equal to 3. This is greater than or equal to 3. Okay. Now we will do this question. Now, Roman 3 second problem. The number of elements in the set A. Number of elements in the set A is equal to 12. Now, the number of subsets of A is nothing but the number of combinations of A. Therefore, the first question, the number of subsets containing 4 elements means number of combinations that can be made from 12 elements by taking 4 elements at a time. So that is equal to 12C4. is equal to 12 into 11 into 10 into 9. 12C4 by 4 into 3 into 2 into 1. So simplify this answer. And the next question, second question. The number of subsets containing at least 3 elements. At least 3 elements. That means number of combinations containing at least 3 elements. At least 3 elements means 3 or more than 3. That means combinations with 3 elements, combinations with 4 elements, combinations with 5 elements, plus and so on, combinations with all 12 elements. Now we can write this as total number of combinations that can be made from 12 different elements minus the combinations made without any element, combinations made with one element, and combinations made with 2 elements. So on simplifying this, we get the answer. And third question is number of subsets containing at most 3 elements. At most 3 elements means less than or equal to 3. Every combination should contain 3 elements or less than 3. Less than 3 means it may contain 0 elements. So combinations with 0 elements plus combinations with 1 elements and combinations with 2 elements and combinations with 3 elements, not more than 3. So this is the value for that. Okay. So these are the questions and concepts from the combinations. So you can do these other problems in the exercise. So do it as assignment. So these are the concepts and problems from the combinations. Okay. Thank you.